Hey guys, I'm just going to film this short video for our stats class, and I'm going to go over question 13 from assignment 7. This deals with the sampling distribution again, and it's got two parts. It's a pretty easy question, and it's sort of just a review of some stuff that we've done before. I'm basically just using this to help me study for the quiz, and I hope it helps you too. So, we're given some information about female pulse rates. We're told that they're normally distributed with a mean of 72 beats per minute and a standard deviation of 12.5 beats per minute. So we can just start to pull information out of our question that we need. We can see that our mean is 72, and it will be that way in both parts, so we can fill both of these out. And our standard deviation is 12.5. So then moving on to part A, we've selected one adult female, and we need to find the likelihood that her pulse rate is less than 78 beats per minute. And this is actually just a review of chapter 6 or assignment 6. We really don't need to do any extra math, and we don't need to bring these formulas into play, although we could. But really this is just simple. Our number under consideration in this case will be 78. And you can see that I have the graph here, and really what we're doing is we're just calculating the area under a non-standard curve. So for that we can use norm.dist, and we can just press equals and start typing the formula. Double click to complete. X, our number under consideration, 72, our mean, 12.5, our standard deviation, and our true flag, which we will always use in this class. And we will see that we get 0.6844. And if we wanted to express that as a percentage, it would be 68.44. And over here we can see that that's the correct answer. Next, we're asked, okay, well, what if we pull out 16 women instead of 1? What's the probability that they have pulse rates with a mean less than 78 beats per minute? So for this, we're going to bring our formulas into play. And the first thing we're going to do is we're going to address n. N is the size of our sample, and we're told that that's 16. Now we need to find the standard deviation of the sample mean, and that's what this formula does, and that's what this represents. This is the standard deviation of the sample mean. So to do that, we'll first just do it in steps. First, we need to find the square root of our number of people in the sample. So in this case, we need to find the square root of 16. And while I know it's easy, we know it's 4, we can use the square root function, which is right here. And we will do it just to show how it works. And now we're going to divide the standard deviation by the square root of our number of people in the sample. And we're going to get 3.125. And this will become the denominator in our new formula, where we're converting this 78 into a z-score. Effectively, we want to know what this z-score is, so we can use norm.s.dist to calculate the area under the curve. And these numbers aren't useful to us in the form they're in until we convert them into a z-score. So in this case, we need to know the mean of 78 or less. So our sample mean will be 78. And now we can build this formula down here and convert all these numbers into our z-score. We're going to press equals, and it's going to be the sample mean minus the mean. Close our bracket, and that's the top part of our equation. Then we're going to divide by the standard deviation of the sample mean, this number here, and press enter. So we can see that this right here, this line represents a z-score of 1.92. And now that we have our z-score, we can use norm.s.dist. We just double click to complete with our z-score, and it's cumulative, to get 0.9726. And to express that as a percentage, close to 100%. There's a pretty high likelihood that all 16 women are going to have pulse rates less than 78 beats per minute. And we can see over here that that's how we arrive at the right answer here. And that's everything for this question. That's question 13.